All right, so Keith is our next speaker. He's from Microsoft, and he was actually the first one that I confirmed for this. I thought about this when we were doing it, and one of our former members is now Keith's boss. And so I called him up and said, Steve, can you help us out? We've got this data analytics forum. I think it's really cool to have somebody like Microsoft there. And he got me in touch with Keith right away, and Keith committed to this. So I'm really looking forward to this one. So I'm going to turn it over to you.
Great, thank you. Appreciate the chance to be here. So I'm glad you did get in touch with my boss. Yeah, so it's almost over. We got one more sort of official talk and then the Ignite session, which will be fun. So I hope you're looking forward to that. Just a bit about myself. So I started off education as a chemical engineer, but took some computer science classes, and over time gradually gravitated more and more towards software and applied math, analytics. So in graduate school, my research was actually on gene expression array analysis. Then I went and postdoc at IBM, where I worked at functional genomics group. Then I defected to the dark side and went to Wall Street for 9 years, where I was one of those quants and rocket scientists that ruined the world. I actually had nothing whatsoever to do with mortgages, so don't blame me.
Boo by association.
What's that?
Boo by association.
Exactly. But I actually, after a while, I wanted to get back to working with people who were doing tangible things and making products that were contributing to life and the improvement of society. And, because one day my kids asked me what I did for dinner or for work, and I said, well, I take other people's money and I move it around. Every time I move it, I take a little bit. And they thought that was awesome. Like, oh my God, that's the best job ever. But to me, it just felt empty after a while. So I was very fortunate to get into Microsoft because I worked in the manufacturing team. So now I'm exactly where I want to be, back to roots, working with people like yourselves who are doing real and tangible things. So I love my job, and I'm a data solutions architect, which means I help people, work with people like you to come up with strategies and combinations of products and services and people to deal with whatever data related, on the information side, the content of data related problems you have, or goals that you're trying to achieve. So that's me. And here's what we're going to talk about today. So, and I'm very thankful for the previous talks. I'm actually kind of happy to go last because they set a lot of good groundwork for some of what we're going to talk about here, and you'll see how the things that they told you so far really feed into some kind of practical examples. So those are the examples we're going to cover, and they're kind of ordered in a certain way, which is we're going to talk about examples where this thing not working, I forget about that, where just collecting data, new data that was dark, added value. And then an example where they had tons of data, but they didn't have compute, and adding the compute created value. An example where they had data and it was clean and connected to compute, but no model, no understanding of the data, that added value. And also the importance of automation. And then closing that loop back to some type of control that actually affects valuable changes in a process. And we're going to talk some about people. One of the very important elements in everything we do. That's the agenda. And please ask questions anytime you feel like it. I love to be interrupted with questions. The polls, yes. Poll number 1. Which of the following best describes your current data footprint? Okay, so very little digital data, we don't have any sensors, we need those, or we've got data, but it's being measured but not connected. We've got connected data, it's messy and disorganized. We have clean, awesome data, but we just can't get any value from it. Or, we're awesome, we're just here to hang out. Tell you guys what's up. Cool. Interesting. So it's a nice little bell curve, which is a pseudo data scientist I would get excited about. that A is just not willing to admit it. They're actually here. They're just not testing. Yeah. All right, so it's interesting. And C, earlier in the data science talk, we heard about how organizing and cleaning up the data is a lot of work. It's very hard. It takes a lot of work. It's tedious, but yet it's a huge value driver. And so I'm not surprised to see a lot of you are in that situation. We've got the data, it's connected, but it's just dirty and ugly. We need to clean it, get value from it. So next survey question. Oh, somebody did that. No. Right at the end there, snuck in under the wire. So, which of the following describes your data science capability? And there was sort of a similar question to this before is, you don't have adequate data science capability, you're getting it through partners, you got it through internal staff, or some combination of those. And hopefully you all put in your bids for the data scientist and the auction. It's out there. Did you see it? Now, what's kind of interesting about the survey is if you recall an earlier survey question that was kind of surprising was a large number of you had multiple data scientists, I think the question was, on staff. And yet, they're still not adequate, there are not enough of them to fulfill your needs, right? Not enough capability. Now, maybe that's, if that's because they're working on other things versus there's just not enough of them, how many people would say it's because they're working on other things and they just haven't been tasked with the manufacturing aspects? How many say that? How many is just, there's just not enough capability, not enough capacity? Okay. Final question, I'm gonna have to take notes on this one, which is, how would you rate the potential value of advanced analytics within the next 5 years? And not really, value, schmalue, not really that valuable. Okay. Yeah. I will tell you, this is sometimes the kind of pressurizing comment that's made a lot of times is, look, we got to do this or we're gonna be destroyed. So I'm actually, it'll be interesting to see if that doom and gloom kind of how that plays out over the next 5 to 10 years. I can tell you that one of the most profitable oil refiners in the country point blank said, hey, look, if we don't digitally transform, our company's going in the dumpster. So they're definitely quite paranoid about the possibility of being displaced, even though it seems hard to imagine, right? Such a capital-intensive industry. Okay, so let's keep an eye on this chart here, 44-48, about 50-50 split. So why now? Why are we having this conversation now? Why has MAPI organized this event? Why are we here this year? Why now? Okay, what's changed? Well, the things that are changing, and some of these have been mentioned as well before, is that it's never been cheaper and easier to connect up data sources. Okay, nowadays you can connect up, if you have a factory that has a wireless mesh, or for some reason or another you can get away with hubs, you can get wireless compute chips for $10. That's how little they cost. Now, of course, they have to be in some enclosure and whatever, but the point is really cheap. So we're able now to cheaply and easily get the right data at the right place at the right time. And that connected data is connected to something quite new, which is hyperscale compute. And what does hyperscale compute mean? It means that the cloud providers they can essentially build capacity faster than you'll consume it. And by the way, working for a cloud provider, we welcome you to dispute that and to challenge us. Please do. We're happy to take up that challenge. So you can essentially treat cloud as an infinite resource, because for for practical purposes, it should be for you, at least for now. Maybe one day this will change, but for now. And because of that, you can now derive advanced value from computations that you would have previously been prevented from doing. Because, for example, if you need a result in 24 hours, and whatever compute cluster you had would take 4 days, that's a qualitative problem. It's just we can't get the result we need by the time we need it. Cloud changes that because you can use dynamic or on-demand capabilities to spin up enough computation to get the job done as quickly as you want. So it's a qualitative difference. It's not just some, well, it's cheaper, faster, whatever. It actually enables things you could not do before. Okay. And because of those two things, there's this current explosion of investment all over the place in taking advantage of that. So companies, startup companies springing up that are offering advanced analytics, new capabilities. Large cloud providers are plowing investment into analytics people, data science, new technologies, etc. So it's there's this momentum that you can all take advantage of and participate in too as well, contribute to. So where do you start? I mean, you're like, okay, I'm convinced we need to do this. At least, the bulk of you were convinced that it offers significant value to you. Where do you start? Well, you can start top down by thinking about where are our business problems, figure those out, and figure out if we've got the data or what kind of data we need to get to solve the problem. You can also gain inspiration from just inventorying the system, what you have available to you. Help me derive value from the data I have today. So just inventory what you have and think broadly. Think about lots of the dark data that's sitting around. Maybe weather data is important to you. We have customers who they believe humidity has a lot of impact and they need to do some humidity control in their manufacturing. Weather data, there are, of course, telemetry from sensors. There's maintenance logs, failure logs. So think kind of broadly about all the data that you have. Work with your subject matter experts to think, okay, here's all the stuff we have. What are the problems you face? Where are the pain points that can intersect with this data? Okay, and then you have to ask yourself some questions once you've kind of gotten an idea of what data you have and maybe the problem you're looking at. The better the raw materials, the better the product. I thought this was a quote by somebody, but I couldn't find who it was, so it may have been me. I don't know. I'm going to steal it if I can't find it eventually on Google. But garbage in, garbage out, right? And with garbage data, machine learning lets you make garbage decisions with a high degree of confidence. You don't want to be in that situation. Okay, so you got to first figure out, is your data relevant to whatever problem you're trying to solve? For example, if we're trying to predict when the engine on some truck that say always drives 65 miles an hour is going to fail, measuring its speed is not that useful because the speed is being controlled. The guy's pressing on the gas pedal, RPMs are increasing at the expense of oil temperature, etc. So you have to measure other things. Is the data that we have actually relevant to the question? Is it accurate? Is it full of all kinds of null values half the time? And as Dr. Borgi can tell you, null values are a pain to deal with in data science, and especially if things are going null, not null, sometimes not. Is the data just wrong? Is some sensor, giving -1 all the time? Or here's a funny example. I was with a customer, we're walking around the factory, and he's talking about how important it is to track, this batch of raw materials when this batch of product. And so we walk over to where the product's laid out, and I just looked at one of the batch numbers, and it's like batch 111111. And I thought, man, this is really weird. Did we just happen to walk up on batch 111111 just today? Oh, well, yeah, I guess so, because it should be, let's check the other one. Batch 111111. So somebody is just going 11111111, enter. Right? There's no sort of automated system to increment that, batch ID. So, well, okay. we got a problem there. We need to deal with that underlying system because otherwise we can't analyze batches at all, right? Is data connected? Well, we have data, but we've got to get it connected up to cloud or to other data so we can actually use it. Maybe we want to connect, we have multiple factories, we want data between them to contribute to the analysis. Got to get it connected. Okay, is it big enough? Now this one, I'm really cautious about having that up there because there's kind of this idea that, like, I have to have a certain amount of data in order to do, like, I'm never going to come to you and say, oh, how many samples do you have? Well, we have 29. If you had 30, I could help you. But with 29, nothing we can do there. It doesn't work like that. The more data you just get greater accuracy and precision and sort of performance for the models, but there's no kind of cutoff. So don't be shy about starting with what you have. Just go ahead, start. The data science process will tell you whether or not it's sufficient to meet your goals. So just try it out. Okay, and then is it modeled? We're going to talk about this later on, but you have to understand that humans play a critical role in the process of data science. It requires human expertise both on the analytical side as well as the subject matter side of things. There's no magic yet. Okay, but I'm going to talk more about that later. So fire extinguishers. By the way, anytime you see the name Contoso, that's because I can't tell you the name of the company. This is Microsoft's fictitious company, Contoso. It has a website and all kinds of stuff. So today we're talking about the division Fire, Contoso Fire, which produces fire extinguishers. But this was actually a real fire extinguisher company. Okay, and they had heavy usage of compressed air, with something like 82% of manufacturing facilities use compressed air as an essential power source. And they had observed that they were getting a lot more sort of continuous flow and compressor usage than they should have been. So they suspected leaks. Notoriously those systems are leaky. And when you leak air, that's kind of expensive because it takes something like 8 horsepower of input to get 1 horsepower of energy from the compressed air. So you're wasting energy and they had 2 miles of piping all over the place. So they needed some way to cheaply monitor flow rates throughout the system so they could zero in on where the leaks were and go and find and fix them. And also not just to fix them once, but to monitor it going forward when new leaks arise. So what they do? Well, they turn to Synapse Wireless because they offer a LED lighting system that also serves as a wireless mesh that allows them to go around and connect up lots of little stuff cheaply in the factory. So they put sensors, throughout, they put 16 of them throughout the 2 miles of piping. And on their 2 compressors, they put a bunch of other sensors, temperature, vibration. They should have put an ampere, sensor on there, but they didn't know about you yet. I'll tell them. And they have this idea that there's bright data, dim data, dark data. This is how Synapse views things, and they believe that this dark data is very valuable. That's the idea behind mesh connecting up all this stuff. And by the way, in addition to connecting up those things we already talked about, putting in the mesh and connecting, they decided just as like a sort of fun thing to do for their tours, okay, that they would monitor the fire extinguishers. They produce fire extinguishers, remember, on their tour route, just the tour route. So they put these location tracking, which just said whether or not it's in its bracket or what sort of nodes it was nearest to, and some proximity sensors that said whether or not somebody shoved a box up next to the thing and included the access to it. That was just for fun. Okay? And what they find? Well, the good news was they found leaks and eliminated leaks, and believe it or not, they reduced the total power consumption in the plant by 5 to 7%. Not bad, right? The total consumption. Okay, but there was another surprising result. from the fun side, which was fire extinguishers were disappearing from the tour route. Okay, no incident reports of them being used, no explanations. Anybody have any thoughts on what was happening to the fire extinguishers? Yeah?
To replace an defective product or something,
No? Anybody else?
For production, that's not good.
That's good, yeah. So what was happening was there were actually fires that the employees were not reporting. There were fires. They investigated and found out that there were fires. Somebody was grabbing fires, putting it out, going away, not reporting it. Okay? And when asked about it, they said, well, there weren't fires, they were just smoldering units. Okay? So, you know, that's a safety issue. And it's a governance issue. And so just they collected this data, they had no clue they were going to find this, right? But they discovered something important. So somebody had asked earlier, you know, should we let data science drive what data we collect, or should it be the other way around? Sometimes you just don't know what value you're going to get out of data. And so you should kind of think broadly when you're thinking about, you know, where you can get value. So asset tracking may be valuable. Smoldering events. Yeah. So how about if you've got tons of data but no compute? Well, that was a situation Miami-Dade was in, and by the way, that's in Florida, and they're you know, the 7th most populated municipality in the country, and they're 1 meter above sea level, which maybe causes them some issues. They have 100 water supply wells, 1,000 sewer pump stations, 39,000 fire hydrants. You see the numbers. And they had a vast SCADA system collecting data all over the place. Flow rates, pressures, the pumps had more instrumentation, obviously. And their issue was that, you know, they had 22 years of archived history of this. They were trying to analyze this on-prem with Excel and SQL. And it would take days just for a basic analysis of one pump station, and months to kind of analyze the whole history of pump station. Because of just the vast quantity of data that they had, and the systems, the computational capability. Okay, they couldn't do any type of holistic analysis of everything that's happening in the municipality, and they were having problems, especially with sewage intrusions, the polite word for sewage getting into somebody's house, okay, or somewhere else important. And in 2013, the EPA said, hey, look, you're like one of the worst, you know, municipalities at this. You got to do something better, and we need documentation and blah blah. All these kind of, you know, hammers came down. So they approached a company, and you know, that company helped them. And it was really just a lift and shift. You know, they just took the data that they had, got it up into the cloud. Sorry, I forgot to remove Azure from up there. They got, you know, and this could be AWS. It's the same thing. It's simple lift and shift. They just moved it. Data Factory is a periodic ETL tool. There's lots of those around. Moved it up into the cloud. Okay, 15 billion rows moved. And it dramatically changed things for them, because now they can do their analytics in, you know, seconds or a minute or whatnot. So the engineers loved it. They were able to much more effectively monitor the system, respond quickly. So if a break happens in a pipe, it takes a while for it to undermine the foundation and create sinkholes and whatever else. So they now had time to respond quickly and get there and fix it. And they significantly reduced sewage intrusions. So I have noticed they've still been having a problem here and there, working on it. But the EPA is happy with the progress and improvements that they've made, and they're thinking about extending it to other systems in the municipality. So all they needed was compute. What about, you've got data, you have compute, but you just don't know how to get value from it. So this is a modeling example, cooling load prediction. But before we get to that, I want to talk more about the role that humans play in modeling, okay? So chess is a well-defined, simple game. You learn it as a kid, maybe. Okay, it has 1,500-year recorded history. Tens of millions now of recorded games, and 50 years of computer science, hardcore computer science research into how to make computers play chess. Heuristics, algorithms, etc. A lot of the machine learning stuff we use today was driven by this, among other things. And sure enough, computers now annihilate people. Okay, anybody's phone in here or their laptop can destroy Magnuson. Okay, he when this chart was made, he was rated 2882, the highest rated player in the world. Komodo, one of the best, chess playing algorithms, 3393, which means he's destroyed, has no chance of winning. Okay. And by the way, this has changed now. I need to update this because AlphaZero from Google is now rated, I think, 4100 or something. But it wouldn't change this thing I'm about to show you, which is, despite this, if you take cyborg chess, which is people playing augmented by machines, so Komodo or AlphaZero is doing its thing, but a human sitting there helping it with pruning branches, saying, don't bother with these lines, or I want you to do king side attack, queen attack, something like that, are better than computers by themselves. So that's Kramnik and Anand, two grandmasters, and also two people who are very well known for both playing cyborg chess as well as anti-computer chess back when people could still win, or handicapped anti-computer chess. And they're playing in the cyborg tournament. Okay, and cyborgs beat the best computers 65 to 85% of the time. So people, even in this well-defined, well-studied, simple scenario, add significant value to the process. So now when you talk about a factory with lots of complexity and real-world stuff going on, and nobody's been studying your factory for 50 years, okay, people are an essential part of the model. So, for example, they wanted to predict chiller load from 3 variables: outside air temperature, wet wall temperature, and humidity. They want to be able to predict upcoming load on the chiller so that, for example, if the facility has the capability to make ice and burn ice, they can do that before the load or when power's cheap or whatever. Okay. And they tried, if you just do some simple fit here, you can explain sort of 47% of the variance of the chiller load based on these variables. They wanted to know if they could do better. They wanted to do better. So they asked us to help them, and in this case it was me. So I'm just some guy, okay? And they were like, oh, this sucks, we want to make the prediction better. By the way, some partner of yours, we paid them something and they didn't get it done. What happened? This is the first time we heard about it. Okay, well, take a look. So I got their data. I spent like a weekend thinking about it. Well, guess what? As people have noticed when they go out here, it's much cooler outside than in here. Part of the reason why is all of us are generating heat. Okay, people are a large heat generation source. And so I thought, well, if there's this workforce coming in and out of the building, maybe there's some latent heat generation. So I decided to augment the model. And I added in a variable for every hour of the week, 7 by 24, of this unknown latent heat generation. And then just I went over into, this is like ML Studio, sort of like our version of Infiniminer, or Rapid Miner, or Enterprise Miner. I guess it's not Infiniminer, Enterprise Miner. Infiniminer's a game. Just build this model, okay, added in some custom Python code to do that little piece that wasn't part of the stock modeling capability, and ran the analysis, and that's what I saw. So this is the latent heat generation, throughout the week. And immediately, a human being can see this and go, wow, cool, we found something. Those dotted red lines are 8 a.m., 4 p.m. So during the week, there's clearly a workforce that comes in before 8, leaves before 4, and it kind of dwindles down throughout the week there. And Friday, people start getting out early. Not many people on Saturday and Sunday. So this is clearly a human phenomenon. And by the way, before doing this, I had already gone to gather solar irradiance data to account for that. Didn't help much. This is why, because you can see the sun doesn't know about Saturday, Sunday, right? Even though it has a similar actually heat pattern. Okay, well, did it improve things? Yeah, it went from 47% to 62%. And by the way, they just gave me 1 year of data for one building. That's it. So you do much better with more time, more data, better models. But the point behind this example is that it took a human being to think about things and augment the model in a very useful way. Whereas it would have taken a neural network much more data to achieve the same thing. It could have, in theory, achieved it with a hell of a lot more data. So people play a crucial role. All right?
Or after evaluating every other alternative, right?
Say again?
Or after evaluating every other alternative, it may not have come to that conclusion as quickly, given all that data.
Sure, yeah, that's possible too. Yeah. Because, we don't give enough credit for what our noodles are doing up here, and the fact that we're going off of thousands of years of accumulated human knowledge. That's worth a lot of data. So now we have this model. How do we use it? Well, these days it seems the industry at large, the world at large, really has settled upon web services as just a very flexible way of deploying things. Even on-prem, by the way, you can use web services. Okay. So you take that model, you deploy it as two web services, a training service and a scoring service. And just their request response, HTTP. And what does a training service do? Well, you send in your request, a specific set of historical data that you want to train the model with. And what it gives you back is typically just a response saying training successful, because the actual tuning file, it could be a really big thing that you may store somewhere else, like in S3 or Blob or wherever, right? So you store that training file somewhere, respond back, I'm done now. So you can use that training service again to train a different data set. Okay, and then the scoring service takes in telemetry, or it can be at any point, but it takes in real-time, data, for example, and gives you back the model prediction. And it's tuned with a tuning file. Make sense? So there's a training service, scoring service. And the scoring service you would have running pretty much all the time. And you may have, in the case of these chiller people, they have different buildings, okay, that would be trained. So they would have a scoring service running for each of those buildings. So the general pattern is you've got a model, maybe you train that and you just have one trained model and you have thousands of devices connecting to it. That's one possibility. Maybe you have a tire pressure sensor monitor and they all just use the same model. Sometimes you may have, say, a dozen or so different models for different kinds of machines, the extruder, riveting machine, and then you'll create trained instances of those, and then all the extruders will connect to the extruder model, all the riveting to the riveting. This customer was actually in a slightly different scenario where they had one model, but needed to train every building on its own data. So all their thousands of buildings needed to have a specifically trained instance of the model for each of their own buildings, and it would connect to that model, that web service. And that didn't quite fit into the normal sort of scheme of things. So in those kind of cases, you turn to scripting. Just write some scripts to automate things. So you choose whatever scripting language you want. I did it in PowerShell because of some convenient libraries we had. And believe this is only the whole script is 2 pages or something. Really not difficult to do this. Created a script, actually a couple of scripts, that either can be run whenever you want, or in an automation service in the cloud, or as a web service, by the way, that's triggered however you want. And what does it do? Well, the scripting coordinates this process where it takes a model, it invokes a training service with a certain data set, and there will be a pool of training services, because it may take a while, say 20 minutes to train a model. If you got 1,000 buildings and you're doing it, say, on the weekend, retraining all the buildings, you gotta have a pool so the job gets done in a certain amount of time. So we'll just round robin through, grab a data, or specify the data set to one of the training services. They would produce these training files. The script would then patch the appropriate scoring service for this training file, and then that creates the trained scoring services, and then the buildings connect, to their service. And they also used it for research as well, because anytime they want, they can actually run those scoring services in batch modes, where they tell it, hey, look, go grab this data set and analyze the whole data set and write the results somewhere. So they can do it for the research process as well, using the same method, which allows them to easily scale the compute however they want. They're using web services. Any questions? Nope. Stunning silence. So Hershey's, this is kind of a fun one. Hershey's, that's George from Hershey's, but not George Hershey. That's another George. They extrude Twizzlers, and they come in these packs. And the pack says it has whatever, I don't know, 5 ounces or something. How many ounces are in there? I have no idea. And it has to contain at least that much. Can't contain less than that, or there's problems. But anything extra is lost product. You're not getting paid for it. Okay, and the way that this extruder works is it's got this batch or this giant cauldron, and every once in a while some licorice gets dumped into it while it's getting extruded. So it's dumping in licorice and it's also extruding at the same time. And so they wind up with this temperature variation in the batch, which causes the density to vary, which means if you just extrude at a constant rate, you get different amounts of licorice coming out, okay, which creates variability in the packs. And because you have to have at least what you advertise, you have to kind of assume worst case variation, and you wind up with lots of lost weight of a product. They want to do better. So they took one of their extruding batches and they added 22 sensors to it, a mixture of temperatures at different places, weights at different parts of the thing, as well as fluid height measurements. Sampled it every second, stream this data up to the cloud, use ML Studio. Again, it can be any, the point here is this is, we want easy tools that subject matter experts can use. So for example, Rapid Miner, Enterprise Miner, ML Studio, whatever. The idea is to try to so-called democratize machine learning, because right now the issue is we have data scientists who know how to do analytics, but they don't know much at all about these subject matters that they're working on. We have subject matter expertise, who have years of experience, and they know a lot about the engineering, but they don't necessarily know how to do data science. And while universities are trying to produce bridges, individuals who have kind of a hybrid knowledge base, it's going to take a while to fill all those gaps. So along the way, we also want to take people who are subject matter experts and help them advance their ability to do at least some prototyping machine learning, or to get somewhere where they can communicate that to a data scientist and say, hey, look, I found something interesting. Can you take a look at this in greater detail or more sophistication, right? But they're incorporating their knowledge and communicating it to the data scientist. So they went and built this model. They streamed the data up to it in real time. In their scenario, they don't need millisecond latency to get back and forth. They just need to know, kind of predict what's happening in the extruder, alter the rate of extrusion. Okay, so they could afford to stream it up to the cloud, get back optimal extrusion rates, and they didn't close the loop fully. They still had an operator, because it was a test scenario, observing that result and adjusting the rate, but it could have gone to a servo and automatically did it, right? Change the rate. They reduced their weight consumption by 1.5%, which for them translated to $750,000 in annual savings for this one extruder, one of many. And now they're extending it to other units, other kinds of candy, okay? So what about people? You know, one of the big problems I know that you're probably all facing is that you have a retiring workforce. And that workforce has decades of this knowledge that we already know is very valuable for modeling, for understanding the system. Okay, and it's going to get lost if we don't do something about it. So an interesting way to make use of that knowledge, to codify it in a way that's immediately useful are chatbots. Because you can have and when I say bot engineer somewhere in here, that's actually not something, there aren't official bot engineers these days. But what they are is people who know how bots are programmed, and they also have the ability to converse with subject matter experts to kind of mine their knowledge. So you can have, somebody sit down with the very experienced subject matter experts, ask them questions, interview them, okay, to extract that knowledge for them in a way that is very well defined so it would work with a chatbot. Okay. By the way, chatbot's not a Microsoft specific thing. Everybody's talking about chatbots, right? If it's capitalized here, it's not meant to be. It's just a chatbot is a generic kind of thing. Okay? So they sit down and ignore that this is not manufacturing specific. I'm going to change that slide there, but they have this conversation, the bot engineer, the subject matter experts, things that look like this, how do you know when machine RxM5 needs maintenance? Well, definitely if it's running hot, it needs maintenance. Hot anywhere? Well, no. Now see, that's the kind of thing the bot engineer thinks about, because they know that a machine is dumb. It doesn't know that there are some parts that maybe should be hot, some that shouldn't. So they ask these questions. And no, some parts are meant to be hot, but if the bearing case is hot, that's a problem. How hot? Well, if you flick water at it and it sizzles, then it's too hot. Okay, so they have this conversation. And then that gets translated into some code form, Lewis or some other JSON or whatever the bot framework you're working on supports. Okay, you translate that into these rules and code in some language, usually it's JavaScript or something like that. And then you wind up with this, bot now on the other side. And then the conversation, it's become this interactive incarnation of that subject matter expert's knowledge, and then the conversation looks like this. Hi there! Which machine are you checking? RMX 055. Do you know where the machine bearing case is? Now, assume that we've got somebody fresh out of somewhere. They don't know much at all. So the thing to ask them lots of questions, like, do you know where the bearing case is? Yes or no? Because if they don't, it's going to show them. Here's where it is. Okay. Yeah, I know where it is. Okay. Please ready your temperature probe. Have a mobile device, hook the probe up, and attach it to the center of the bearing case. Okay, I've done that. And now the chatbot can actually get the data if you set up that system. Remember, web services is the way you would do that usually. Yes, I see the data now. The temperature is 228 degrees Fahrenheit. The bearing case is overheating. Request an immediate bearing service. And it can even say here, is that okay? Can I request the bearing service? And automatically do it. Connect up to a system and submit that request. So that's it. Now, an example architecture, what does this kind of stuff look like? You have IoT devices, machines, process historians, and you have what are called data agents. Those are just whatever that helps you pull data from that, or they can communicate directly to some IoT ingestion point. You're going to store data in structured stores, unstructured stores. You can do stream processing, machine learning, automation logic, create bots, digital twins, whatever. This is visualizations. This is just kind of a general outline of what that kind of architecture might look like. And as we talked about, web services will play a big role in that. So what have we covered? Let's first figure out if anybody's changed their mind. Okay? So this was actually a test. It's the same question as before, and I just want to see if anybody's been altered by this presentation. Too early to tell. It's too close to call. Hold on. That's pretty interesting to me. So if you guys remember, it was like 50-50 here with 4% above and below. We moved. So we're starting to see more possibilities of how to derive value from analytics and data. And so not only can you see the value for yourselves, but you can see how if you don't start embracing these trends and these technologies, there's going to be more advantage for your competitors. So I'll pause there. I think we have plenty of time for questions, I think. Yeah, we got 10 minutes for questions. So, any questions? Yes, sir.
Can you highlight a little bit more about the chatbot? I'm not familiar with that, right? And we have a lot of workers that are around 20, 30 years, right?
Mm-hmm.
Retiring workforce and whatnot. Can you give a little more information around it? Is there, kind of, how would you go about it? Is it the conversation with those employees?
Well,
or how do you?
Yeah, it is, but you first want to get, if you don't have internal expertise at building chatbots, you want to get a partner who has that expertise, because it's a different thing to think the way a computer thinks. You have to think in a very rigid, detailed kind of, well, what about this corner case and that case? And so you need somebody who has that knowledge of how these things get built, and also has the ability to converse with a subject matter expert to have the conversation with them. So it's about sitting down with them and interviewing them on whatever if they're the expert on a vibration analytics or a certain machine or whatever, they would interview them about that and ask detailed questions to guide them into the sort of extracting that knowledge from them.
So there's chatbot software you buy or a program, and as you're having a conversation, it's picking up the information.
Oh, no, this is so hold on. So the first step is a bot engineer, which is a human being, sits down and has this interview process. They make a whole bunch of notes. They go back to their bot company, code a preliminary bot for you, and then your subject matter expert would interact with that bot to test it and do quality assurance, and then you would have some new people interacting with it. So it's kind of an iterative process like that. But it involves, first and foremost, it has to involve some people who know how to build chatbots. And there's free frameworks for building the chatbots, and they're just web services. In fact, you've already run into them if you've gone to websites where this annoying pop-up comes and says, "Hey, you've been looking for 5 seconds. Do you need help?" No. I see you're still here. Do you have any questions? Those are almost always chatbots. They're not real people. They're chatbots. Now you can code chatbots so that if a certain sequence of things happen, it can transfer control to a human being. Where they can take over. Like, for example, you can do sentiment analysis. If you're a hotel chain, you can do sentiment analysis and figure out that somebody's getting upset at the chatbot. Maybe they're looping around through some cycle they can't escape from. And then a real person will come on and go, hey, what's going on?
Thanks.
Any other questions about this or previous topics? Yes?
Is there any typical blend of resources for a successful data science project? Other than the data scientists obviously being involved, what are the types of resources you typically see?
That's a good question. I know some of our earlier experience, why don't you give that a shot? Akshat, I think you probably know better than I do.
Sure, I can answer it. So, in my opinion, a data scientist in isolation is not empowered with the right tools to successfully drive a full project. For example, in our company, we have a data scientist who's working on very specific problems in signal processing, but there's a lot of infrastructure you need around that. So, for example, we need a really good CTO, for example, who can direct this person on the appropriate business problems. Additionally, typically data scientists come from a math-heavy background and are pretty comfortable developing algorithms, but they need data engineer who can help them deploy those systems at scale. You also might need the right integration engineers who can pull the right data sources. And also, I believe you need someone on the sales or on the operations side who can translate what is the core of the business problem, because that might influence the approach in a really meaningful way. So to answer your question, I think you need a team to really support, and it depends on what's the context of business problem.
Yeah, I would totally second the comment about the sales engineer, because a lot of times data scientists tend to be quite academic, and so they might tell you something like, well, you know, if we can't do what you want to do with the current thermostat, why don't you just send out guys to reprogram all the thermostats? Because you realize that's a huge undertaking in a production scenario, software has to be verified, et cetera. That's no small thing to do that. So it's good to have the sales engineer, because they'll have more business perspective, having interacted with lots of customers and heard their concerns, you know, many times over. So they can help kind of get the data scientist pointed in the right direction and say, like, no, look, we really have to run this on the edge, okay? Like, because they can't go down if they lose their internet connectivity. So,
one last comment, maybe retaining data scientists is extremely challenging. Everyone wants their own data scientist. And I think creating a program in place that's really engaging and educational for them allows you to actually retain them. So I think sort of playing to what data scientists typically really want to grow into is important. So a strong mentor, whether it's internal or external.
yeah, and that was a question that came up earlier about, I think the majority of people here said that they were trying to build internal data science teams rather than outsourcing to partners and things. Understand it's a big undertaking, and it's going to take a long time to achieve the productivity that you need out of them. So don't wait until you have your own center of excellence or whatever created. Go ahead and at least start on some projects with partners, whoever they are. Yes?
In your experience, how often does external data marketing this information really add value to a data science project? Or is it primarily just the data inside the four walls that you need? Does it really need the external data to add that extra value to put it on the market?
Yeah, so so far in my experience in the current state of the industry as a whole, it's primarily internal data that people are deriving value from, primarily because being able to aggregate external data sources is kind of a future thing. It's something we're trying to work towards. I mean, as a whole, getting greater interoperability and communication. And like, for example, obtaining that solar irradiance data was a real pain. It took me a long time to kind of dredge all that sort of stuff up. There was no easy, way to do it. And you end up, if you try to do that kind of stuff, you end up writing a bunch of web scraping and all sorts of things that are very fragile. They require teams to maintain that. And yeah, so right now it's primarily within the four walls or within different sites in the same company. There's a lot of value there. So, we've got data from our facility in Brazil and here and, the Czech Republic and whatever. Integrating that data has a lot of value, but that's still within the same company. So, yes.
So, years ago, we always had this struggle between, more hardware capabilities or just better coding. So, I can double the speed of my ERP system just by getting my DBAs to be more disciplined in their structure.
Yep.
Well, now you've kind of won the war as far as horsepower, right? And are you seeing a growth of just, and maybe you can't tell, of just bad structure and bad data out there? And since we can hit it with so much horsepower, certainly it's a revenue generator for Microsoft.
Uh-huh.
But are we shooting ourselves in the foot?
Interestingly enough, the opposite is happening.
Okay.
Because before, what's the result? So I've got my local cluster on-prem here or whatever, and I write some crappy code. Well, now the report just takes an hour and a half instead of 1 hour to complete. So maybe somebody sends out some annoyed emails, how come whatever, it's taking so long. But at the end of the day, nothing happens. Nobody gets in that much trouble. You don't buy new computers to make it faster. What happens in the cloud is it's all been reduced to money. So, hey, why did our cloud bill go up from $20,000 to $24,000? What changed? Well, I don't know. We'll go back and look at the logs. Well, so-and-so released, a patch to such and such application. Okay, well, hey, look, it's costing us $4,000 a month. Go figure it out. So it's funny because once everything's been projected into a dollar space, there's actually a lot more oversight into how much that's costing. Now, to be fair though, there are a lot of cases where companies are willing to just get something done, to get proof of concept complete, to figure out what the value is, and maybe it's running inefficiently, but they often come back to that very soon and say, okay, good, we've got a handle on what kind of value this can generate, now we have to do it for cheaper, because it's costing us X amount. And then they'll put resources into optimizing.
Yeah, I suppose it would be hard to tell when you've got your example, light, dim, and dark data, and you may want those structures out there, you just don't want to access them. It's hard to tell how much should we spend on the cloud. If we're doing better analysis, maybe the payback is in the licorice example. Yeah. We're all getting less candy because it works.
I don't think anyone's happy about that.
Right, so there's it's at this early in the game, it's kind of hard to tell. And maybe that's where applying a good data scientist at that critical level right now. Got somebody disciplined helping them build the structures that are efficient.
Well, believe it or not, that's actually the domain of the data engineers and Dr. Borges' kind of taxonomy. It's really the engineers who will optimize things and make them more efficient and that sort of stuff. So, and they'll be under the constraint that it has to produce the same results that whatever. And actually, this breakdown is the same as it is in any other field. For example, I was chemical engineering, right? And our professors used to tell us, okay, chemists figure out how to make stuff. We figure out how to make it cheaper and more of it. So that, there's this dual relationship between scientists and engineers. So if you think of the scientific method, which is observe, hypothesize, test, and then very importantly, repeat. Because if research worked the first time, it'd just be called searching. Right? There's a reading there for a reason. Well, that testing part is a control process. You've heard about experimental control, whatever. So what scientists actually do is they leverage control to gain knowledge. Engineers leverage knowledge to gain control. So it's the data engineers that would, once the knowledge of what we need to do, how we need to do it, has been put in place, they're the ones who will start to control that process, make it better, and get it to do things in the real world.
Thanks, Steve.
All right.
Appreciate it. You have one more slide, or is that it?
That's it.
Okay. So right now, we're scheduled to start our Ignite session at 3:15. So let's take about a 5 or 8 minute bio